Hi, doing transformations today. There are four types of transformations: translation, reflection, and rotation. A transformation is when a shape or a graph changes in size, location on a coordinate plane, or orientation, meaning the direction it's facing. A pre-image versus an image. This is another set of vocab you need. So a pre-image is the original image, and we label a pre-image with letters like A, B, C, D. Okay, so maybe it's a square, and it has sides A, B, C, and D. The transformed image, that's the pre-image. The transformed image is what we call the image. It's the result of a transformation. And we label the image with letters and prime. So it looks like A prime, B prime, C prime, D prime. A prime is where A has been transformed to. So if I have another square that has been just shifted over to the right, we would write A's vertice as A prime, B as B prime, C as C prime, and D as D prime. So we know that the D prime vertex and the D vertex were originally the same, or the one derived from the other. Okay, there are four types of transformations: translation, reflection, rotation, and dilation. Okay, a translation is right here. A translation is when when the shape, the object, the graph is moved, and each point is moved the same distance and direction. And informally, we call the transformation a slide. Okay, so again, let's check this out. If I call this A, B, C, and D, A's vertex would move to become A prime, B goes to be B prime, D becomes D prime, and C becomes C prime. Each one of these line segments is exactly the same length because they're moving the same distance. Okay, second type of transformation is a reflection. We call it a flip. So, and it's over a certain line. So right here in the visual, this dotted line is called the line of reflection. I usually highlight it. Okay. And what happens is each point, and it's is the same each point of the image and the pre-image are the same distance from the line of reflection. Oh, there's a typo here. Each point of the image and pre-image are the same distance from the line of reflection. We call this a mirror or a flip. So if I look at my shape, I'm going to call this my pre-image and my image. So my pre-image, if I call that point A and this is A prime, they are equidistant from the line of reflection. We'll say this is B and B prime. The distance to the line of reflection here is the same as the distance from the line of reflection from B prime. Okay, C and C prime. So the distance is each of these points is equidistant from the line of reflection. Lastly, let's call this E for funsies, and E prime. E is the same distance to the line of reflection as E prime is the same distance as to the line of reflection. Okay, I don't know if we said this already, but we sometimes call a reflection a mirror or a flip. A rotation is when we turn the figure about a fixed point. So we usually say about like the point 0, 0, or about the origin, or you can list any ordered pair. Okay, so here it looks like we are turning about the fixed point right there. So this point is going to turn 90 degrees clockwise to becomes A prime. The point up here, B, turns 90 degrees clockwise to become B prime. So its orientation means that it's the same shape but facing a different direction. Okay, clockwise is opening to the right, counterclockwise is opening to the left, or turning to the right and turning to the left. Okay, we informally call a rotation a turn. Oh, and when we talk about a rotation, we need to say that the direction it turns, and the degree it turns. So over here, we would say that we're going to rotate 90 degrees clockwise, or 270 degrees counterclockwise. So we could say it opened up 270 degrees that way. Those are the same. All right, a dilation is a little different because it produces an image that is the same shape but is a different size, okay? Which means that the vertices are the same size, so the angle measures are the same as the original, but the sides are scaled, which means that, which we call a scale factor. To find the scale factor, we use the image length over the pre-image length. So if we look at our diagram over here, we're going to say that the pre-image is that's the original, okay? The original image is on the right, and we're going to change to the image on the left. So what I'm looking at is what is the ratio between the image to the pre-image, okay? So I'm going to write that down as 6/4 reduces to 1.5, or 3/2. So that means that all the sides here are times 3/2, or they're 1.5 times larger. Another thing I can do is look at all of the side lengths, the image to the pre-image. 12/8 should be equal to another ratio of the sides, so 15/10, and another ratio of the sides, 9/6. Let's do the original, 6/4. 6/4. The ratio has to be the same for every single set of side lengths, or corresponding side lengths. So here we will divide by 4 to give me 3/2. In the blue, I can divide by 5, giving me 3/2. 9/6, I can divide by 3, giving me 3/2. And 6/4 will divide out a 2 in the top and the bottom to give me 3/2. So these two shapes are proportional, or they are a dilation of one another. Or we would say the shapes are a dilation because the scale factor is the same for the sides. Okay, so what happens if your scale factor is greater than 1? Right here, greater than 1. It means that if you're like taking 2 times your height, you're going to grow. Okay, if your scale factor is times 1/2, then think about your height times 1/2, you're going to end up half the size, so you're going to shrink in height. Okay, if your scale factor is 1, so me times 1 is going to give me exactly the height of me, so I stay the same. All right, what happens to the shape when you perform a translation, reflection, or rotation? So we call these 3 transformations rigid transformations, okay? Which means that the shape itself stays the same side. So all the side lengths are the same, all the vertices are the same angle measure, but maybe the direction or the location changes. So they're exactly the same size, just moved into a different spot or turned a different way. Okay. All right. So we're going to name the transformation for the image to the pre-image to the image, A to B. So A is our pre-image. I'm just going to go ahead and write A is the pre-image, and we're moving to B, which is the image. So we're facing the same direction, and the shape just has been moved up. So this vertex moved here, this vertex moved here, this vertex moved here, all 1, 2, 3, 4, 5 units, 1, 2, 3, 4, 5 units, 1, 2, 3, 4, 5 units. This is a translation. It's a slide. Next, B. Okay, this one's facing a different direction, so it can't be a translation. If it's a reflection, the image should mirror itself, so it should look exactly the same, but facing a different direction across a line. I can see that this vertex right here turned to become that one. This vertex turned to become that one, and this vertex turned there. This is a rotation. Okay. We had to turn the image. This one looks like a mirror of itself across the line y equals 0 is our line of reflection, which we'll call LOR. Okay, so this is a reflection. Each point is equidistant, so 1 unit, 1 unit, 1, 2, 3, 4 units, 1, 2, 3, 4 units, and then 1, 2, 3, 4, 1, 2, 3, 4. Yeah, so each corresponding point is equidistant from the line of reflection. All right, D. D cannot be completed in one transformation. So, but you can do a combination of transformations. So let's do an example. I think that if I take A, let's see if we can do this. Okay, and we rotate it. This is going to change its size, sorry. Rotate it like that, and then we reflect it, which I don't think I can do with this. Nope. Okay, so if I flipped the image over to become like this, oops. Oops. Let's try it again. So I'm going to rotate it to there, and then I'm going to reflect it like that, and then I'm going to go ahead and slide it over. So we were able to flip, which is, or rotate, reflect, and then slide, which is a translation. So we used all three. Okay. Go ahead and figure out what these 4 transformations are really quick, and then we will go over them. Okay. So A is a reflection, but across x equals 0. C is a reflection across y equals 0. B, it looks like we just slid, so that's a translation, excuse me. They're all transformations. And then D, this short side is going to turn down to be the bottom, and then the tall side, if we turn it, is going to go vertically. So this is a rotation. You can say clockwise 180 degrees or counterclockwise 180 degrees. It's the same. Okay. All right. So dilation. Are these So in order to be a dilation, so we already know that these figures are similar because it says in the directions, which means that the side lengths have an equal scale factor. So use our clues to find our scale factor first. Example 3 shows us that first off, we need to label that this is the pre-image is A and B is the image. So to find the scale factor, we do the image length over the pre-image length of any corresponding sides. So I have a side length of 2 and a side length of 5 that are corresponding from the image and the pre-image. So I'm going to write 5 over 2. That reduces to 2.5, but I'm going to leave it as 5 over 2. Okay, my scale factor is 5 over 2. Does that mean our shape is going to grow, shrink, or stay the same? Okay, remember this is 2.5. That's greater than 1. This is greater than 1, so we're going to grow. So from the pre-image to the image, did it grow? Yeah, I would say so. All right, now what is the side length y? Now since the side length on the left is 5 and on the right it's 5, that means that the 2 and the y are the same. Okay, 7.5 and 7.5, so all I need to do is set 7.5 equal to x or z because they are the same. So I'm going to do the image 7.5 over the length x equals 5 over 2, because remember each of these corresponding side ratios should have the same scale factor. We go ahead and multiply. So cross multiply. 5 times x gives me 5x, and 7 times 2, 7.5 times 2 gives me 15. Divide by 5, and x is equal to 3. So x is equal to 3, which means z is also equal to 3. All right, next one, the scale factor. So find a set of corresponding sides, and I see that 12 and 3 are corresponding because they are across from the widest, they're both across from the widest angle. So this is my pre-image and my image. So I use 3 over 12, and I reduce by 3, giving me 1 over 4. So my scale factor is 1 over 4, which is less than 1. So are we going to shrink or are we going to grow? We will shrink. So look at your diagram. Does the image to the pre-image to the image, does the shape shrink in size? Okay, good. Yes, it shrinks. All right, now we have to find the lengths of M and N. So let's start with the 8 corresponds with M, and the 6 corresponds with N. So I set this 8, it's the image over the, this is the image over the pre-image. So the pre-image value is M over 8 is equal to, and I use my scale factor, 1 over 4. Cross multiply, giving me 8 is equal to, 4m, and then divide by 4. Okay, so m is equal to 2. So m is equal to 2. And then I'm going to make that blue. And then next up is n over 6 in the purple. And you don't have to use the reduced scale factor. You can use the one that we used earlier, 3 over 12. Okay, cross multiply, giving me 12n is equal to 6 times 3 is 18. I divide by 12. So n is equal to, let's see, divide by 12. 18 over 12, I need to divide by 3, giving me, oh, wait, let's divide by 6. That's a better number. 3 over 2. Okay, so the value of n is 3 over 2. All right, so basically it's a fourth the size, all the side lengths are a fourth the size of their original. So 3 is a fourth the size of 12, 1.5 is a fourth the size of 6, and 2 is a fourth the size of 8. Last one. So how can I tell if if the new TV is a dilation of the old TV? So remember, the new TV is the image, the old TV is the pre-image. So how could I test to see if these are the same? Well, first off, I notice they are both rectangles. So they have all the same vertices. So first we gotta check the angle measures. Are they the same? Yes. Okay, now we have to check the ratio of sides. So let's take the vertical side, 16 over 20. 16 over 20. Okay, so 16 over 20, we will reduce that by 4, giving us 4 over 5. Cool? Yeah. So it shrinks, that makes sense. All right, next we'll do the side lengths. So the image is 9, the height is 5, that reduces to 9 over 5. So are these matchy-matchy? Are they the same? Same? No. So that means that the figures A and B are not dilations because the scale factors are different. We have 4 over 5 and 9 over 5. Okay. The sides need to grow or shrink by the same scale factor. If not, your shape is just a whatever. It's not a dilation. And that's it. Bye, guys.